Hello everyone. So today we're going to learn about L'Hopital's rule. I know it's spelled a little bit different and pronounced a little bit different. I'm pretty sure it's French, so just go with it. So we've done limits in the past where we were doing algebraic methods, and we're going to learn one more method today, especially now since we're so good at those derivatives, okay? So sublimits cannot be found using algebraic methods. Okay, if a direct substitution produces one of these two indeterminates, so remember the 0 over 0 or infinity over infinity, before we were able to say, okay, if it produces 0 over 0 when substituting in, then there must be some way that we can simplify it. And a lot of that had to do with some factoring stuff that we could cancel out. Then we could do substitution. But what if we can't simplify it anymore? But we can't just keep it as 0 over 0. So this is where L'Hopital's rule will help find the limit. So here's what it says. The limit as x approaches c of f of x equals 0, and the limit of x approaches c of g of x is 0, or if they are infinity over infinity. So see how we have the f over the g, so we would have 0 over 0, or infinity over infinity if we plugged in. Then we can use L'Hopital's rule to allow us to continue forward. L'Hopital's rule, what does that mean? Well, it means that we can take the derivative of the numerator and the derivative of the denominator and then plug it. This is kind of really cool, okay? But most important thing, we can't just substitute in and say 0 over 0. They actually will not give you points for that whatsoever. What you need to do is kind of put it in this form. So when we write down that we're going to use L'Hopital's rule, we have to explain why. So what I can do is say limit as x approaches infinity of x, which is that numerator, is infinity. The limit as x approaches infinity of that denominator, e to the x. Well, think of e to the x, your exponential, right? So as you go to infinity, where does our graph go? It goes to infinity. So in this case, now I've indicated that we're going to have infinity over infinity. So what we can do now is actually take L'Hopital's rule, which means we're going to do the derivative of the numerator, derivative of the denominator, okay? So what I can now say is a limit as x approaches infinity. Well, what is the derivative of the numerator? 1. What's the derivative of the denominator? That's e to the x. And now I can substitute in, right? I'm looking at 1 over e to infinity. Well, e to the infinity is very big, like infinity, and 1 over a big number is 0. Remember, a limit is not exact value, it is where it's approaching. Okay, let's see on this one. Again, I have to indicate, look, I want to try L'Hopital's rule, so I need to just look at the numerator. So e to the x, and that's infinity, where limit x to infinity of the denominator, well, that's infinity. So now I can talk about the derivative using L'Hopital's rule. So now I look at limit as x approaches infinity. Well, let's take the derivative. So e to the x derivative is e to the x. And the denominator, well, x derivative is 1. Don't forget, this isn't the quotient rule. It's taking the derivative of the numerator, derivative of the denominator. And now when we plug in, well, e to infinity is infinity. Done. Okay, what happens here? Well, again, I look at it, I'm like, I'm not going to be able to do any algebraic reduction here. So let me look what happens. Limit as x approaches 0 and then of x is 0. But if we look at the denominator here, x approaches 0 of e to the x, well, e to the 0 is 1. So this is not indeterminate form. So not indeterminate form means we just plug in, which is 0 over 1. So the answer is 0. Awesome. Good. All right, let's look at 4. Let's see. As we can see, we're not able to do L'Hopital's rule, or we are able to do L'Hopital's rule here. You want to think of it like, well, I'm not going to algebraically be able to reduce this. So let me see if I can use L'Hopital's rule. So limit as x approaches 0 of 3 minus 3e to the x. Well, when I plug in 0 here, 3 times 0 is 0, e to the 0 is 1, 1 times 3 is 3, 3 minus 3 is 0. Let's try the denominator. So x, well, that equals 0. So this means I can use L'Hopital's rule, and I'm going to state my limit. The derivative of the top, let's see, well, the derivative of 3 is 0. Then I want the derivative here, right? So we've got negative 3e to the 3x times the derivative of that exponent, which is 3. And then the derivative of x is 1. Now we can plug in. When we plug in, we get negative 3 times 3, which is negative 9. Okay. Number 5, it's saying that it wants us to do the limit without L'Hopital's rule. So, of course, the first thing we look is like, hey, if I plug in right now, I get 0 over 0. So there must be a way I can simplify it. And you guys see how we can simplify it? The top has a common, a greatest common factor, and then the difference of squares. So the top is 2 times x plus 1 times x minus 1 over x minus 1 plus 1, sorry. And then these two cancel. So what I'm really looking at is limit as x approaches negative 1 of 2 times x minus 1. So now I plug in, right? Negative 1 minus 1 is negative 2. Negative 2 times 2 is negative 4. So this is using our algebraic way and canceling. This is the same problem. We're going to use L'Hopital's rule here. But first, we must prove by saying limit as x approaches negative 1 of the numerator equals 0. Limit as x approaches negative 1 of the denominator is 0. And because of this, it means that I can do the limit of x approaches negative 1. Now I'm going to take the derivative of the numerator, derivative of the denominator. So the numerator's derivative would be 4x, and the derivative of the denominator would be 1. Now if I plug in, substitute in, I get the value of negative 4. And you both get the same answer. L'Hopital's rule is awesome because all you got to do is prove that it's the indeterminate of 0 over 0 or infinity over infinity, and then you could do L'Hopital's rule. Now, the algebraic way, the problem is with that is what if we come into something that we can't simplify algebraically, but we have to use L'Hopital's rule. So from now on, guys, if you get a 0 over 0 or anything like, or you're indeterminate, you don't have to algebraically simplify it. You can use L'Hopital's rule, which is derivative of the numerator over derivative of the denominator, and then plug in. you'll see also what's awesome is you could do L'Hopital's rule, substitute in, and then still get an indeterminate. And you can do L'Hopital's rule again and again if you want. But we got to indicate that we can use it. And of course, I couldn't teach you this until you learned your derivatives, right? All right. So that's what this is saying on top here, is saying, hey, if we want to do L'Hopital's rule twice, we are able to do that, okay? But each time we must prove that each part happens to be that indeterminate, that zero or that infinity. So first thing first, I know I can't simplify it, and if I plug in, if I just look in my head, right, I'm gonna get negative infinity squared is infinity, and e to the negative of negative infinity, well, that's infinity. So I am gonna get infinity over infinity. It means I must state it. X that goes to negative infinity of x squared equals infinity. Limit as x approaches negative infinity of e to the negative x. Well, when I plug that in, right, that would be e to infinity, which is infinity. Now I know I can do L'Hopital's rule. So now I can say limit as x approaches negative infinity, take the derivative of the numerator, which is 2x, all over the derivative of the denominator, which is negative e to the negative x. But then if you look at this and we plug in again, we find, wait a second, now it's negative infinity over negative infinity. I still have to state it, right? I have to say the limit as x approaches negative infinity of 2x equals negative infinity. Limit as x approaches negative infinity of negative e to the negative x. When I plug that in, I get negative infinity, which means I can do L'Hopital's rule again because it's negative infinity over negative infinity. So L'Hopital's rule again states that I can say the limit as x approaches negative infinity, the derivative now of the numerator is 2. The derivative of the denominator, which would be e to the negative x. Now, when I plug in, I get 2 over infinity, right? That's what we stated before, that this was infinity. 2 over infinity. 2 over a very large number will approach 0. Okay, let's try this again. Let me break this out so I know I have room. All right, so limit as x approaches 1 of ln of x minus x plus 1. Well, ln of 1 is 0, leaving us with negative 1 plus 1, which is 0. So that numerator turned out to be what we wanted it to be. Limit as x approaches 1 of x squared minus 2x plus 1. When I plug that in, I get 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So we get that indeterminate. So now I can use L'Hopital's rule. X approaches 1. So let's take the derivative of the numerator, which is the derivative of ln is 1 over x. The derivative of negative x is negative 1, all over 2x minus 2. All right, let's see what happens here. Because if I did this quickly in my head, I would get 1 over 1 minus 1 is 0. And 2 times 1 minus 2 is 0. So I'm going to have to use L'Hopital's rule again. But again, I have to indicate that why I can use L'Hopital's rule. So I'm going to say limit as x approaches 1 of 1 over x minus 1 equals 0. Limit of x approaches 1 of 2x minus 2 equals 0. This indicates that I can use L'Hopital's rule. Now, I will try to find out if we have to actually write on the side L'Hopital's rule, or if you can just go as we're doing it. Okay. So limit as x approaches 1. I'm going to take the derivative again. So remember that this is x to the negative 1. So that would be negative x to the negative 2. The derivative of negative 1 is 0. And then the derivative of the denominator is 2. Now, when I plug in, you'll see that 1 to the negative 2 is 1. That's a negative 1 on top, 2 on the bottom, so our answer is negative 1/2. So these two problems were just showing you how you can actually do L'Hopital's rule a bunch of times as long as you keep getting that indeterminate status. Be careful as you're doing your work. Sometimes you can use L'Hopital's rule, sometimes you can't. Just don't assume that all of these are going to be using L'Hopital's rule because we just learned how to do it. You have to recognize when you're able to use it and how you can prove that you can use it. Okay, guys, have a good day.